Hello everyone, welcome to Engineering Bookshops. For this video, we're going to solve problems on our Engineering Mechanics Statics about Chapter 2, Moment of Force about a point. So I am going to solve problems 2.22 to 2.30. But here in this video, I am just going to solve 2.22 to 2.26 and the continuation will be on the other video. So, okay guys, so for our problem 2.22, we need to find moment at A. So this is our given figure. So we have 800 force Newton and 38 degrees. So first we need to find our x and y components. So for our x we have 800 cosine 38 and for our y we have 800 sine 38. So to start solving for our moment at A, so I will assume clockwise positive. So here guys, you can also assume counterclockwise positive, so it depends on your assumption. So since I assume clockwise positive, so this 800 cosine 38 is positive since it will rotate clockwise in clockwise direction. So 800 cosine 38 multiplied by its moment arm, 0.6. And this one, it will rotate counterclockwise. So therefore, since it is counterclockwise, so our sign will be negative. So it will be minus 800 sine 38 multiplied by its moment arm, 0.5. So I will use calculator for us to solve. So 800 cosine 38 rotating in clockwise direction. So it is positive based on our assumption, and then minus since it is counterclockwise. So 800 sine 38 multiplied by 0.5. So our answer will be 131.98 kN meter. So since our answer is positive, so therefore our assumption, which is clockwise, is correct. So our answer will be 131.98 or 132 Newton meter in clockwise direction. Okay, so for problem 2.23, we need to find moment at A and B. So this is our given figure. So for us to solve for our moment A, so I will assume clockwise positive. So here, you can use either of the two. You can use this component or this component, but I will choose this component because as you notice, this y component is already at A. So meaning it will not going to rotate at any point because it's already at A. So meaning it is already equal to 0. So here, I will just use this x component to take moment at A, and it is rotating in clockwise direction. So therefore, based on our assumption, it will be positive. So 300 cosine theta multiplied by its moment arm, 0.6. But what is cosine theta? So if you notice this right triangle, so I will simplify this one. So our cosine theta will be adjacent side, which is 10. And our hypotenuse is square root of 3 squared plus 10 squared equals to square root of 109. So this will be our equation. So 300 positive since it's rotating in clockwise direction. Cosine theta adjacent side over hypotenuse. Adjacent is 10. Hypotenuse is square root of 109 multiplied by its moment arm, 0.6. So our answer is 172.41. So if you try to use this component, it is okay because it will just give you the same answer. So I just choose this one because it will just lessen our equation. But if you choose this one, so this will happen. So 300, so cosine theta, so our cosine theta is 10 over square root of 109 multiplied by its moment arm. So its moment arm will be 0.9. So it is rotating clockwise direction, so it will be positive, and then this one is counterclockwise, so minus sine theta, so 300 sine theta. Our sine theta is opposite side, 3 over square root of 109 hypotenuse, and then multiply by its moment arm, 1. So the answer will just give you the same. 172.41 Newton meter, and since our answer is positive, so therefore our assumption, which is clockwise, is correct. So for our B, take moment at B. So just like A, I will choose this component. Why? Because as you notice, this is already at B, so therefore this will be 0 for our Y component, and we will just going to use our X component. So for our X component, we have 300 cosine theta adjacent side over hypotenuse, 109. 300 cosine theta multiplied by its moment arm, 0.9. So the answer will be 258.61 Newton meter in clockwise direction. But again, guys, you can use this component. So by just showing you, so 310 over square root of 109 multiplied by 0.6. So it is positive since it is clockwise direction based on our assumption, and this is clockwise direction also. That's it's why it will be positive. So plus 300 sine theta, 3 over square root of 109 multiplied by its moment arm, 1. So it will also give you the same answer. Okay, so let's try to solve problem 2.24. So for problem 2.24, we need to find distance B. So based on our given figure, we can create this figure for us to solve the problem. So it is said on our textbook, there is a hint that saying that the moment of force P about a point is equals to the moment of R about the same point. So therefore, this will happen. So if we take moment at C, so it will be P multiplied by 2.5. So this P here is already 0 since it's already lying at point C. And here for our R, we have Rx and Ry. But our Rx is already lying at point C, so therefore it will be 0. And Ry, we need to take moment at C, so it will be Ry multiplied by B. So from this equation, we can solve for our B, but we need first to find Ry. But what is our Ry? So Ry will be positive P. So P plus P quantity sine theta. So what is our sine theta? Our sine theta is opposite side, 3.5 over hypotenuse, 2.5 squared plus 3.5 squared. So from this one, we can solve for the value of our P. So for our P, it will be 1 plus 3 over 3.5 over square root of 2.5 squared plus 3.5 squared. So it will be 1.8137p. So this will become like this, and we need to substitute this Ry here, and as you can see, we can cancel p here if we try to substitute this one, and this will be the remaining equation. So 2.5 equals 1.814b, and from here we can now solve for the value of our p. So it will be 2.5 divide 1.814, and this will be the value of our b, 1.378 meter. So that is for our problem 2.24. Okay, so for problem 2.25, we need to find force P. So this is our given figure. So we have 200 Newton meter rotating clockwise at point O, and 0 for our moment at A and B. And since for our moment A and B is equal to 0, so therefore our force P is passing to our point A and B. So therefore we can create our X and Y component either of the two point. So it can be at point A or it can be at point B. So using at point A, so this will happen, P cosine theta multiplied by its moment arm equals to our moment O, which is 200 Newton meters. So this will happen. So P, our cosine theta, is 0.4 over hypotenuse square root of 41 over 10 multiplied by its moment arm 0.5. So it will become 200 over zero 0.4. So since this one is clockwise, so therefore this will be also in clockwise direction. So 0.4 multiplied by 10 square root of 41 times its moment arm 0.5. So it will give us 640.31. So if we try this component, it will just give you the same answer. So we are just going to use sine. So P sine theta. So it will become 200 over our sine is 0.5 times 10 square root of 41 multiplied by its moment arm 0.4. So it will just give you the same answer. So if you need to find the single equivalent force P, so okay, so for our P again, so we can rewrite this ones for I and J, so 640.31 cosine theta for I, so 0.4 adjacent over hypotenuse square root of 41 over 10, and then minus 640.31 sine theta, our sine theta is 0.5 over square root of 41 over 10. And then our answer will be 400I minus 500J. So let's check. So alpha A multiplied by 4 over square root of 41. Square root of 41. So it is 400I and minus 500J. So 5. There we are. So this is our final answer for our problem 2.25. Now, try to solve problem 2.26. So it is just the same on our problem 2.25. So we need to find our force P. So this is our given figure. And we have, based on our textbook, we have given at point O, 80 Newton meter rotating in counterclockwise direction. And for our point A, we have given 200 Newton meter rotating in clockwise direction. And our moment at B equals to 0. And since in here, so our moment B is equal to 0, so therefore our force P is passing through our point B. So therefore we are going to create our component here at our point B, and we can now solve our force P. We can now start solving for our force P. So rotating, taking moment counterclockwise positive. So here, so Py multiplied by 0.4 is equal to 80. So we have our Py equals 200 Newton. So 80 divided 0.4 is 200 Newton. And for our Px, so we need to take moment here at our at point A. So Px multiplied by its moment arm 0.5. So rotating counterclockwise positive plus then 200 times 0.4, so which is our Py, 200 times 0.4 equals, so since this one is rotating in clockwise direction, it will be negative 200. So we can solve Px equals to negative 560. And for our P, we have negative 560 I for x and plus 200j